There's a mineral in your kitchen that absorbs more heat pound for pound than almost any building material ever tested, not a rare earth, not a refrigerant, but salt, an industrial salt that melts at 90 degrees and swallows over 100 BTUs per pound. In 1948, an MIT chemist heated a Massachusetts house through winter with no furnace, and today, monitored German buildings use that same chemistry to cut cooling loads by double digits, 0 moving parts, 0 electricity. Yet not one major American builder offers it, so here's the question. This video answers, if a $40 bag of salt can do a compressor's job, who decided you'd never find out? Long before compressors existed, 3 continents moved heat with salt. India dissolved saltpeter into water cold enough to frost the bowls in the 1500s. Rome packed salt into snow to get colder than ice alone. Persia paired brine pools with mud brick yakchals to store ice through 120-degree summers. And Africa's Zir pot, a sweating clay vessel, chilled food on physics alone. Different empires, no contact, same discovery. Certain salts swallow enormous heat as they melt. That knowledge sat idle for 400 years until 1948, when Maria Telkes, a Hungarian-born MIT chemist the press nicknamed the Sun Queen, turned it into a building material and paid for it. She fixated on Glauber's salt, a cheap factory byproduct melting around 90 degrees, right where a room turns unbearable, and with architect Eleanor Raymond and philanthropist Amelia Peabody, 3 women with no institution behind them, built a Dover, Massachusetts house that heated itself all winter on sun-warmed salt. Telkes insisted the material works in reverse too, pulling heat from a July room as readily as from sunlight, which matters because your AC fights hardest in the afternoon, when the grid charges most, yet MIT did not reward her for it. Here's the number that changes everything. Raising a pound of water. 1 degree takes 1 BTU, the baseline every HVAC engineer uses, but a pound of melting Glauber's salt absorbs over 100 BTUs while barely changing temperature. The energy breaks its crystal structure instead, latent heat. The salt sits inert all morning, melts right as the room turns uncomfortable, a thermostat built into chemistry, and at night, once air drops below 90, it refreezes, recharged by sunrise, what engineers call a phase change material. PCM, same physics Telkes proved in 1948. Does it hold up? Dover ran on salt alone for 2.5 winters before the bins failed and the salt separated into layers. A flaw we'll return to, but that's a home running its whole heat load on something cheaper than paint. Modern trials across Europe and the US show cooling energy dropping 10 to 30%. One study using Glauber's salt in a roof measured savings up to 45%. And Germany's BASF microencapsulates it into plaster-matching brick many times thicker. The Department of Energy even set a $15 per kilowatt-hour cost target to compete with mechanical cooling. And the comparison is unfair anyway. PCM runs tens of dollars per square meter. Central air runs thousands before electricity or a 15-year replacement. A bag of salt against a $29 billion industry. So where did this go? It starts with Telkes, MIT's solar fund-favored conventional engineering. By the early 1950s, she was pushed out. Dover quietly retired. It's been swapped for a furnace, not because the physics failed, but by institutional choice. Post-war utilities sold modern as plugged in with campaigns backed by GE and Westinghouse, and window AC sales went from tens of thousands around 1950 to over 1 million a year within a decade. Cooling stopped being a property of the building and became an appliance you buy, break, and replace, while architecture schools dropped passive design. The salt didn't fail, it got outsold, and the rulebook got rewritten around the winter. Houses get approved under Manual J, calculations built around a compressor and ductwork, so a chemically absorbing ceiling has no line on the form. And rebate programs pay thousands toward heat pumps, but nothing for thermal storage in your walls, while code listing costs hundreds of thousands, a death sentence for a small maker. Underneath sits the quiet math. A cooling customer is worth over $15,000 across a system's life. A bag of salt is worth $40. Decades of proven chemistry, sidelined not by conspiracy, but by paperwork and committee tables, one line at a time. None of that stops you. Salt needs no permit, just a hot room and a cold night. You can buy PCM mats today, pouches of salt hydrate or plant wax laid above your ceiling drywall, $30 to $60 a square meter, or go DIY with sealed Glauber's salt containers and a thickener in an attic, which owner-builders in dry climates have used to shave several degrees off peak temperatures with a box fan. The fix nobody tells you, Dover's failure, salt separating into layers, is solved now with a pinch of borax or sodium polyacrylate, stable through hundreds of cycles instead of a few dozen. But the salt must reset, open windows or a fan at night. No night flush means no recharge, and no recharge means no cooling tomorrow, which is why humid nights, the Gulf Coast, coastal Florida, never let it refreeze, and performance collapses there. This shaves peaks. It doesn't replace AC and extreme heat. It shines where days are hot and nights cool, the Southwest, the Mountain West, most of Europe. The Dover House still stands. The bins are gone, but the idea inside them never stopped being true. From India to Rome to German labs, sealing the same chemistry into wallboard today, different centuries, same mineral, the answer was never a matter of opinion. Glauber's salt melted at 90 in 1948, it melts at 90 today. And it'll melt at 90 long after every compressor built has rusted into scrap. No committee can reprice that. No rebate form can repeal it. Maria Telkes died in 1995. Her recognition, the inductions and awards, came decades late. The institutions outlasted her, but her house outlasted their objections. The knowledge was never lost, just never handed to you. Now you have it. So drop your state in the comments. Do your summer nights cool down or stay warm? That decides whether this works on your house. And if your grandmother kept butter cold in a salt cellar, I want to hear that too. If you think real knowledge keeps getting buried to protect quarterly earnings, hit subscribe, because next week, the window design Victorian engineers used to cool entire hospitals, documented by the Royal Institute in 1869, and why modern codes made it illegal.